All right. Now I have a pretty good general feeling of what CarboScen is about and how to use it. But for a few times you've mentioned uncertainties. So I think I need to know a little more about what you mean by them. So in the settings, you have a little box that you can tick that says include uncertainties. And now that it was clicked, there's a new tab called uncertainties. So maybe you could explain what happens now or what should I do next?
Yeah, so in the top part of this page, you have the first of these settings is number of iterations. So the default is 100 here. It's quite low, but let's keep it at that because the results are always now as uncertainties included. The results are calculated each time, and the more there are these iterations, the longer it takes. So you saw like with this computer, with 100 iterations, it took maybe 4 or 5 seconds. So with 10 times more iterations, it would take 10 times longer.
All right. Well, what about it seems like there's two different types of uncertainties, standard deviation and bootstrapping. Do you recommend either, or how do I know which one to choose?
Well, in general, maybe it's a bit more complicated to understand, but I would recommend bootstrapping. I haven't myself. The standard deviation, which I haven't really used myself, assumes a symmetric distribution around the best estimates. For example, there are now 3 rows here. So there's standard deviation of land use area estimate, and the same for biomass carbon density and soil carbon density, for example, which is assumed as 0 here. And then it computes the results, and then there is an uncertainty when the mouse is placed on top of the curves. There's uncertainty range that can be visualized around. That's the 95% uncertainty range. And also when these results are exported into Excel, I did it already, so you can see that previously there were only 3 columns, but now, for example, this is result 1, so it's about area. So forest, or let's look at cropland area, because these are only 100 iterations. Well, it's quite close. It should be 0.8, the cropland area, but because of these random processes, it's close to 0.8, but not quite. The best estimate for cropland area the first year. And the 95% confidence interval ranges from 78.2% into 82.0%. And yeah, the same for all these variables that are generated. And the bootstrapping, which I recommend. So when you click that,
So now there's a load bootstrapping values box.
yeah, so it's from a separate file. So when clicking that, it goes directly into the settings folder. That's the default assumption. And it suggests the bootstrapping data txt file, which is something that comes in the package, just the default case. And I can show from this window explorer where to find it. Well, I mentioned already it's in the settings, and I have now deleted the other file, so this is like a fresh, clean, nobody has used this program so far, but still there is this bootstrapping data, and when opening that, there are some instructions in the top, and then there are values as in the standard deviation approach. Also in this case, there is uncertainty that can be added for forest and cropland, both land uses for area, for biomass, and for soil. And in this case, there is uncertainty only for biomass. And you can see always there are two numbers, for example 77 and 46. So, and because it's biomass, carbon equilibrium values, what is under this heading, so 77 is the actual carbon density equilibrium value, and 46 is the weight that is used in computing the uncertainty. So the higher the second number is, the more this number influences the results. 46 times more than, for example, the first row here. So basically the value 77 and 121 are dominating the estimation of biomass carbon density estimation for forests. So we can look now how the results look like when this file, which you just saw, when opening that. Well, first there is a table which reports that the number of observations is, well, there were few rows with the weight 1, so those add up into 3, 4 or whatever it was, and then there were these 2 rows with much higher weight. So the total of all these is 101, and the mean using those weights is close to 100, and then it reports the standard deviation as well. And when these are now used to compute results, as with the standard deviation method, we can see the uncertainties. There's, in this top left panel, no uncertainty because we assume that the land area data is perfect. There's no uncertainty related to that. The same is true for crop biomass carbon density. But when going into the forest biomass carbon density, we can see that because the equilibrium value had uncertainty, there's now uncertainty on both sides of this red line that we have been watching in the previous clips. And this uncertainty is influencing then not the soil carbon, you see the orange line here, still no uncertainty, but biomass in the whole landscape, it is influencing that. This is the lower estimate, this is the upper estimate. Oh, it disappears when I go too close to it. You can see it here. And then the total, of course, is influenced as well. And again, if you export these, you can find not only the values for these best estimates for the curve itself, but also for the uncertainty range in this exported Excel file.